In this video, we're going to talk a little bit about returns distribution and how it relates to risk. So let's take an example of an asset that has a 10% rate of return and they have a standard deviation of 18%. So how do we incorporate that into the risk discussion? Well, if you think about risk, and you think about a normal distribution is described by the mean or the average return and standard deviation. So when we look down below here, we see these intervals. They are looking at a distribution underneath the normal distribution curve that contains, in this case, 68% of the returns are found underneath that range, or underneath that the bell curve, and that encompasses roughly 36%. So what this is saying is that within one standard deviation, the returns are between -8 and 28, and that covers 36%, or a range of 36%. Again, the importance of this range basically describes how many outcomes are possible within this particular range. Now, what if the standard deviation were 5%? And what we'll see is something will happen to the range. Now, the range, instead of 36%, is 20%. And likewise, if you look down through here, you can find out that the range across the board is going to change every time you change standard deviation. So standard deviation is the measure of risk. I frequently refer to this measure of risk as being a distance. And the greater the distance, the more opportunities for outcomes to occur that are not the expected return. Now, how we can also then incorporate a return number or a performance number is to incorporate the risk-free rate of return. So if the risk-free rate of return were 3%, the Sharpe ratio, this measure of performance, a risk-adjusted performance, would say that this asset has a Sharpe ratio of 1.40. And of course, we would always want this number to be positive, because if it were negative, that would imply that we have earned a rate of return that is less than the risk-free rate. In this case, since we have risk, that wouldn't be an appropriate asset if you couldn't at least earn the risk-free rate of return. Now, of course, what happens as risk increases? If we go back to our 18% standard deviation, we'll see that the Sharpe ratio goes from 1.4 to 0.38, which means, again, the Sharpe ratio is basically telling us for every 1% rate of return, how much risk are we taking, right? What is the risk that is associated with a rate of return? So in this case, 0.389. The lower the number, the lower the risk-adjusted performance of that asset. Now, there's not a lot of things to talk about with respect to this worksheet, but it does, again, give us a picture, if you will, of riskiness, looking at a normal distribution curve.